Good morning. Welcome to the series of Java programming. Myself, Dr. TV Nagaraju, working as an associate professor in Department of IT, MLR Institute of Technology, Hyderabad. In the today's session, we are going to discuss about data type and variables. First, coming to data type. What is a data type? Simply, data means information. The type specifies the type of information. In the simple sense, data type specifies the type of information that is stored in a variable. Okay. Now, whenever we are declaring a data type, immediately every data type has different type of values along with different sizes. And mainly the data types are categorized into two types. One is primitive data type. Second one is non-primitive data type. What is the difference between primitive and non-primitive? Primitive means the basic data type, and the primitive data types are called single valued data formats. Single valued means if you declare a variable as a primitive data type variable, in that variable it is possible to store only single value, that is called primitive data type. And first I will categorize the primitive. These primitive data types are categorized into integer and floating. So, numeric. To store numeric type of data, they given two classifications. One is integer data type, second one is float data type. To store a character, we are using the character data type. Finally, to store a boolean, we are using boolean. These four are the primitive data types. Now, we will discuss one by one. First, coming to integer data type. Now, integer data type is used to store whole numbers. To store whole numbers. What is mean by whole number? A number without any decimal points are called integers. That is whole numbers. Now, by normally, we are using the data type name int, which is used to store an integer value. What is the size? Remember, every data type has some size. So, for integer data type, the size is 4 bytes. You know that one byte means 8 bits. So, 4 into 8, 32. That means if you store an integer variable, the system allocates 32 bits of memory for storing the variable. For example, assume I want to store a value 5. In binary representation, the value 5 needs only 3 digits. Only 3 bits are sufficient. But here I allocate 32 bits, wastage of memory. To overcome that problem, we have another data type short, which is also used to store integer. So, the size of short is 2 bytes. 2 bytes in the sense 2 into 8, 16 bits. Again it is a waste. And another data type is, the data type name is itself byte. So, it allocates 1 byte of memory. Now, you got it? So, data type specifies different sizes also. For example, if your number crosses 32 bits, int is also not sufficient, then you are moving into next one, long. So, the size of long is 8 bytes. So, byte, short into long. These are the 4 variations for storing integer. Generally, byte and short are used for storing multi-stream data. that is a multimedia or streaming data. Integer used in our normal programming. Long is used to store some phone numbers, credit card numbers, PAN numbers. To store such large numbers, we are using long. And one important point, for example, if I declare a variable int a, so here this is a declaration. A is a variable which stores some integer. A is equal to some 123. Okay, fine. For example, C is equal to 256. I assume, for example, or C is equal to, this is some X phone number. System treats this one as an integer. Remember, even though this is a large number, system treats this one as an integer. If you want to make a variable as the long variable, after the value, you suffix with either capital L or small l. Then only that variable becomes a long variable. Otherwise, it is not considered as a long variable. Everyone remember, compulsory you need to suffix with either capital L or small l. So, these are the 4 categories of integer variable. All are used to store whole numbers. What is the difference? The difference is among their sizes. The difference is among their sizes. Whole numbers in the sense, the numbers without any decimal point are called whole numbers. Okay, now coming to next one. Next category is float data type. What is the float? Float data type is used to store real numbers. Real numbers in the sense, the numbers with a decimal point. For example, 2.3, 3.47. The numbers with the decimal points are called float numbers. Now, so for this floating point numbers, 2 data types are there. One is float. Second one is double. So these two are also changed based on size, based on precision. Precision specifies the number of digits that are to be considered after the decimal point. So for float, the size is 4 bytes. Float, the size is 4 bytes. For double, the size is 8 bytes. Okay. And remember, by default, every real value is considered as a double. By default, for example, if I assign the value a is equal to 2.3, system consider this 2.3 is as a double value. For example, my intention is to make that value as the floating value. How? Always the value is suffixed with either capital F or small f. Either capital F or small f. Then that value becomes a float value. Clear the point? That is floating. For example, a is equal to 2.3f. Then only the variable holds the float value. These are the 2 variations that are used for storing real numbers. What is mean by real number? The number with decimal point. Okay, these two are the category for storing numeric data. Remember, data is not only numeric. You have character data is also there. So next category is character data. So character data means simply any single value, already you know that one, single value that is placed in single quotation. A single value that is placed in single quotation, that is called a character. Now char, some ch, any variable. So char, this is the data type. The size of character is 2 2 bytes. The size of character is 2 bytes. For example, char some ch is equal to some x. Here x is the character that is placed in single quotation. Clear the point? That is the character data type. Just to observe, in C language, coming to C language, in C language what is the size of integer? So it is not possible to predict the answer exactly. Why? In some systems the size of integer is 2 bytes. In some system the size of integer is 4 bytes. Why? The size depends on operating system. You already discussed in the last session. What happened? C is a platform dependent. Platform dependent in the sense OS dependent. Internally, operating system depends on the mission. So, architecture dependent. Depending upon the architecture, the size of data type is vary. But coming to Java, Java is a platform independent. You remember the point? Platform independent. That means for generation of the bytecode, Java does not depend on the operating system. Internally, the operating system does not depend on the architecture. So obviously, Java is a platform independent, at the same time architecture neutral. That means it does not depend on the architecture. That is the reason the size of integer is fixed on any mission in Java, that is 4 bytes. Now coming to character, in C language what is the size of character? The size of character is 1 byte. But coming to Java, the size of character is 2 bytes. Why? Remember, C supports only ASCII codes. So, ASCII means American Standard Code for information interchange. For example, capital A, if this is the character, each and every character that we enter through keyboard have some numeric value. Suppose character A have value 65. Suppose small character A value 97. Suppose 0, this is also character, value 48. Not only this, whatever the character you entered through keyboard, everything have some ASCII value. But Java supports Unicode. Unicode in the sense universal code. Here the name specify American Standard. So this is fixed by American Standard. But Unicode means, for example, coming to Russia. Russia have some standards. Korea have some standards. Japan have some standards. Java, that is Unicode, satisfies all the standards of different countries. That is the reason they fixed Java size as 2 bytes. Clear? And finally, Boolean data type. Boolean. So what is the size? The size of Boolean is 1 bit. Remember, the size of Boolean is not byte, a single bit. So the data type name is Boolean, small b. So Boolean means the result 1 bit it stores either true or false. So the two possible values are either true or false that are stored under Boolean. Clear? These four are the primitive data types. Primitive in the sense the basic data type. Without this data type, it is not possible to build any other data type. Clear? This is the main important topic in the today's session. Now, I will give you an introduction to non-primitive data type. So, non-primitive means the group value data formats. The group value data formats, those are also called as referential. What are the different examples? Class. You already know class is a logical structure which consists of methods and variables. For a class, you can define multiple number of objects, and within the class you can store multiple data like class, interface, array, enum. Anyway, this each one is a separate topic. Whenever we are moving on, we will discuss one by one separately. For example, coming to interface is a huge topic. It takes approximately 4 to 5 hours for completion of interface. So, just now I given these are also data types. That means, for example, class, student. Now, student is also a data type of class. Interface like array, we are creating multiple arrays. Okay, these are the concepts of data type. Finally, next I am moving into variable. We already know what is mean by variable. Variable are simply the data holders. What is mean by data holder? Simply the memory location where we are storing the variable. Based on that, up to now we know variable is suppose int a is equal to 5. Whenever you are writing this statement, you know one point. So, some memory is created. Within that memory, we are assigning a value 5. The memory have some address. Anyway, this happened. Based on the data type, the variables are divided into two types. One is primitive data type variable. What is mean by primitive data type variable? The variables that hold values. This is an example. A variable that hold values. Suppose by2, short2, into, long. Next float to double. Next char. Next boolean. Total 8 primitive data types. Now, non-primitive data types. What are the non-primitive data types? Class, interface, array, enum. The non-primitive data types variable will hold object references. Object. What is an object? For example, for a class sample s is equal to new sample of. Here we are creating an object s. We are creating an object s. So, here this object will hold the address. Non-primitive data types will hold the object references. Primitive data types will hold normal values. This is the categorization of data types variables. Okay. Finally, we cover data types and variables. So, what we discussed under data types? Under data types, we discussed what is the primitive data type and then non-primitive data type. Especially our main focus is on primitive data types. Under this primitive data type, to store numeric, we are using integer and floating. Suppose if you want to store a number without decimal point, we are moving to integer, and to store numbers with decimal point, we are moving to float. Again, coming under integer, to store values based on the sizes. The integers are categorized into by2, short2, into, long. They vary according to the sizes. Exactly in the same fashion for floating point numbers, two variations. One is float, another one is real. And to store the character data type, we have one variable char. And the last one is boolean, which is used to store true and false. Okay. Finally, coming to non-primitive data types, those are group value data formats. It can store, it is class, interface, array, enum. And coming to variables, based on the data type, variables are categorized into two types. Primitive data type variable will hold values. Non-primitive data type variable will hold object references. Okay, this is the end of today's session. Okay, thank you.